Alright, today we're going to talk about some slope. There's two ways in which we could talk of slope. We can talk about it as rise over run, and we can also talk about it as the change of y over the change of x. And some people might have seen this in a different form. Sometimes you might have seen it as y2 minus y1 over x2 minus x1. Now, both ways are exactly the same. One is just the shorthand version, in which I like, so that's the way I'm going to refer to it, as the change of y over the change of x. Alright, so let's start with rise over run. When given a graph, alright, rise over run is probably the easiest way to find your slope. And literally, all you need to do is count. So, if we start from A, and we're going to B, we're literally going to count our rise over our run. So how many do we need to go up or down to go from A to B? Well, let's take a look. We're going to go up 1, 2, 3, 4, 5. So I went up 5, and now I'm going to run 2, 3, 4. 4 to the right. So here's some important directions when we're talking about rise over run. If you are going up, it is positive. If you are going down, it's negative. Now, for left and right, this is where people sometimes get confused, and the way that I remember it is with the original Mario Brothers. Because when you're Mario and you're running along the screen, you're running to the right. And at some point, you can't run back left. The screen just kind of stops. So you're making forward progress. We call that to the right, like Mario. So to the right is a positive thing. That's our progress. Whereas to the left is going to be, whoa, screen's acting up. Alright, to the left is going to be negative. So in this case, since we went up 5, that's a positive 5, and we went to the right 4, that's a positive 4. So my slope in this case is just 5 over 4, my rise over run. Simple as that. Alright, let's take a look at my next page. Same thing, rise over run. We're just going to count it off. So again, up and down first, so we're going 1, 2, 3, 4. So we went down 4, and now we're going to head over. We're going to go 1, 2, 3, 5, 6, 7, 8, 9 to the right. So when we rewrite our slope, we went down 4. So remember, down is a negative, so we've got negative 4. And we went to the right 9, so it's a positive 9. So our overall slope is negative 4 over 9. Pretty simple stuff? Alright. So, let's try it a different way. Change of y over change of x. And yes, we're given the graph so we can simply count and go 1, 2, 1, 2, 3, 4, 5, blah, blah, blah. Okay? I want to show you that we can do it another way, because sometimes you're not given the graph. So, A is located at negative 4, negative 1, while B is located at 4, 1. So the change of y. So we're going to take y2, and again, it doesn't matter which one is y2, which one is y1, or which one is x2, which one is x1, as long as you are consistent. So I'm going to take 1, and I'm going to subtract negative 1. I'll show you, actually, you know what, let me back up. I'll show you where those numbers are coming from. Oops. Alright. Alright, colors. Here we go. Alright. And I'm picking the wrong one. Alright, so y2 is over here, and y1. So 1 minus negative 1 over, we've got x2, x1. So 4 minus -4. Alright, so when we have subtracting a negative, it's the same thing as adding a positive. So we'll go ahead and switch those now. So 1 plus 1 gives us 2, 4 plus 4 gives us 8. Simplify all of our fractions all the time, so we end up with 1 over 4. And if we would have actually just counted our rise over run, we would have saw that we went up 2, and then we ran 8. And so we would have had the exact same thing. But again, just showing you another way to do it. So, actually, let me... Alright, special case slopes. So, let's take a look at slope AB. When we talk about slope, I always think about skiing or snowboarding. Alright, you're on the slopes, right? So, let's start with CD, actually. Alright, let me grab my highlighter for you. Alright, yellow highlighter. So we're talking about this super line right here. If you are skiing on that line, is there any challenge to that? I mean, are you like flying off the hill? No, you're going, you're going nowhere. You're flat. You're about as easy as it can possibly get. That's like bunny hill minus like 10. Alright, so when we talk about slope of something like that, we're talking about a slope of 0. It's flat. There's no challenge. Alright, so that's one way I remember it. Now, if we take a look at AB, on the other hand, I'm going to highlight it with a super blue. Alright. So, on AB, if we're talking about a ski slope, I mean, is this a kind of hill that you're going to want to go down? I mean, are you going to make it? Because right now I don't see any traction going on. Some people might be like, oh yeah, I'm going to, take a jump off that and it's going to be awesome. And, well, the only problem is when you jump off stuff, there's some place to land. There's no landing on this one. It's just straight up and down. So this is the one that we don't call, super awesome. We call this one undefined. Alright, or UND. This is the one that is not possible. Oops, I don't know why I wrote that. Alright, that is our don't ever try this at home, folks. Alright, so those are the two special kind of slopes that you should be aware of. And slope intercept form, my favorite. This is the greatest thing since sliced bread, because this is written in such as y equals mx plus b, where m is your slope, b is your y-intercept. 2 parts to the name, and it's written just as we find it. We find our slope first, the intercept second. The y and the x always stay there, blah blah blah, super easy. So if I give you y equals negative 9x plus 1, I say, what's the slope? You better run up to the board, grab the super awesome yellow highlighter, and be like, oh my gosh, negative 9 is the slope. It's the number in front of x. Simple as that. Y equals 2/3 x. Next person, flying up to the board, highlight it. Oh yeah, 2/3, that's my slope. Alright, super easy. Alright, let's go and go backwards a little bit. Alright, if I give you the slope and the intercept, can we make an equation out of it? Well, the answer is simply yes. Alright, because every equation in slope-intercept form is y equals mx plus b. You are just simply plugging in the m and the b. Everything else stays the same. So I can always start by writing my template, y equals blank x plus blank. So all we need to do is fill it in. So again, m is my slope, plug it in, and let's see if I can get green this time. B is my y-intercept, plug it in. And I know some teachers don't like having plus a negative, so you can rewrite it y equals 5x minus 6. I've gotten the question, why do I put the y equals blank x plus blank? Because if this wasn't a negative 6, if it was a positive 6, I've seen people before put y equals 5x 6 with no operation in between. And some people may laugh, but it's happened, so I always put that in there. And then you can, again, you can always just go back through and make it look nice afterwards. Doesn't matter to me. Alright, so again, same thing. Start with our template. Y equals blank x plus blank. Alright, simply plug it in. Slope is negative 1 over 8. We're already told that. The intercept is 3. We're done. Simple as pie, right? Alright, let's not waste too much time on that one. Parallel lines. So parallel lines, we all know, everybody can always tell me, okay, they look like this. And they kind of show me a picture of like what I've got on the side here. Well, the thing is, there's more to it. Parallel lines, everybody knows, oh, they'll never intersect, okay? They'll never intersect. And why is that? What's the same about these parallel lines? Well, if you said slope, you get a gold star for the day. Because if we take a look at the slope of these two lines, we'll do our rise over run. So go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So we've got a negative 4 because we went down 4, remember? And then over 8. That was my red line. For my green line, I use a purple marker just so I keep them separate. We're going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So again, down 4, over 8. They have the same slope. So knowing that parallel lines have the same slope, if I say find the slope of a line parallel to the given equation y equals 7x minus 2, we know that parallel lines have the same slope. My slope is given to me. Okay? Alright. My slope is 7. So all I need to do is write the equation again. Y equals 7x. And then I can just fill in whatever y-intercept I want. If I put minus 2 there, well then it's the same equation. But if I want a line parallel, it needs to be a different intercept. So I'm going to put plus 1. Simple as that. Right? Same thing. Find a line parallel to the equation y equals negative 1/3 x plus 8. Start by writing the things that do not change. Since we want a line parallel, we have to keep the slope the same. And then, again, I'm just going to put plus 1. 1's probably my favorite number. It's super easy to remember, and it's not 8. That's the most important part about this one. So, I hope you guys enjoyed slope, and if you have any questions, check your notes, ask a friend, and if you're still stuck, come talk to me. Have a good one.